title of describing the project I work on for the last 3 years almost, and but for this specific event, right, because the laptop or the internet cut off as well, so everyone dropped.
I don't know, maybe this is, are you guys with us?
Yes.
Now we can hear.
Restart.
This is,
Back up.
Oh, well. Hopefully this is not the nuclear plant or something will be able.
Good, good. First joke. Keep it up.
I have to laugh too.
what was the joke? Hopefully they haven't nuked the nuclear power plant. Was that the joke?
It's too.
Is it working now? Started.
Well,
Can you
the meeting is.
Can you reconnect that over power connection? Can you guys hear us?
Yes, we do.
Do you hear us, guys?
Yeah, we do, and we have been listening to you all this time.
It happened yesterday also, around the same time.
In the beginning. It's very big. Joined late and online.
Can you guys hear us?
Yes, we do.
Okay, very good.
Yes.
Progress.
And do you see the presentation?
Yes, we do.
Okay, nice. We can continue then.
Yeah. Problem solved.
Okay, so what I'll do today, I will talk a little bit about I'll introduce you to the environmental input-output analysis. I'll talk a bit about the specifics of the project, which is called Panorama, that I work on last several years, and then I'll end up with giving some examples from another tool, which is called LCA, Lifecycle Assessment, Lifecycle Analysis. Well, so let's start with the environmental. Let's see how the slides are.
Just use your finger on the chat.
Yeah, you need to click on it and then
it works. Okay, nice. So let's start with an introduction to the input-output analysis itself. So imagine you're a business. I'm quite sure that if you're a business, then you were either yourself interested in calculating at some point of your operation, in calculating the, let's say, the emissions, the greenhouse gas emissions, the carbon footprint of your manufacturing, for example. Or someone approached you from the government or a consultancy and proposed you or asked you to do that for some other reasons. Or you can be a household and you're interested in which producers create less damage for the environment or to support your sustainable consumption, consumers' choices, right? You want to pick the best product out of the available selection in terms of emissions. So the question is, how do the businesses or the consumers calculate the carbon footprint of their production or consumption? And at which point we understand that, okay, this is actually green, this is good enough. What is, there's so much talking about carbon neutrality this day, but what is that exactly and how do you calculate it? Well, I'm not sure if many of you heard about the input-output environmental extended input-output analysis. Basically, in the core of most of the existing mathematical and economic and environmental models to answer such questions. So the input-output analysis is in the essence is a national accounting which is based on so-called input-output tables. It's quite obvious. So what are the input-output tables? The input-output tables, simply speaking, describe your domestic economy, right? They rows, the columns. In the simplest example, this is from Australia. You have the industries in the rows and in the columns. And this table basically describes in a single year in your domestic economy, which industries exchanged goods with other industries in your economy. For example, the food products, beverages and tobacco production, inputted goods from agriculture industry sector worth 12,000 whatever or million Australian dollars in that year. Right, and then in the end, it depends on how detailed your sectors in the economy are described, but in the end, you have a very full picture of how is your domestic economy operating. At the same time, you can argue that every column is basically the production recipe of that industry. What does that industry need to operate? Where does it input the resources and the services from, right? The goods. On the other hand, if you look on a specific row, you can say this row describes what are the outputs of this industry. The agriculture industry exports its services and goods to the following industries in your domestic economy. So this is basically a very comprehensive picture of how your domestic economy operates. Well, what kind of questions can you answer if you have such two in your hand? Well, just to give you an example, you can ask Australian government using this table, ask the question, what happens if I introduce a specific tax in a specific industry in my country, right? And then they analyze mathematically what are the influences in the other industries if you do that, right? So, but these are all financial numbers. Let's move to the next slide. Well, what is, let's move to this specific example. Let's say you have a question. So there's a specific industry in your domestic economy. I'm trying to go a bit quicker now. The insurance industry. And the question you have, how much iron does insurance, single insurance policy worth $2,000 need? Well, to output that single insurance policy, right? So what is the chain here? You can say, okay, I can see the column which describes my insurance policy, and I can see that actually it needs some paper to deliver such policy. You can see how much paper does your insurance sector in your country require. So you can obtain the number of paper per dollar of insurance required in your domestic economy.
Okay, guys, can you put yourselves on mute?
You can continue the chain. You can see that
That was
the wood
Nelson
industry
Thomas
at the
with
same
bubbles.
time requires some paper. Paper, to produce the paper, you need machine to cut the wood in the forest. For the machine, you need steel. To produce steel, you need some iron ore. So all these economic sectors are actually present in the table which I just showed you, the trading one, right? So we can follow the specific supply chain starting from the insurance to the iron ore and answer how much ore does the single $2,000 delivered by the insurance industry, how much iron does it need? Well, the question here could be to you, is this calculation, if you follow your input-output table from the insurance to the iron, will it allow you to answer the question, how much ore iron in total does the insurance policy need?
It's a funny calculation, huh?
Yeah, so in the end, it's 4% of worth of iron ore required to deliver 2,000 insurance. Well, of course not, because that's only iron needed for the paper, etc. Right? So the last slide now presents the complexity of this problem. Right? So what we did right now, we followed only one pass out of basically millions even in the simplest input-output table for the country, which has only few sectors described. The accumulation is so big that there's basically millions of passes from the insurance company to the iron ore. Well, the interesting thing that in the iron, as the company which produces the iron in the end, in its own turn can need some insurance services, right? So the cycle kind of becomes infinite. So in the end, you kind of add up iron, smaller and smaller and smaller quantities of iron to each other. So your sequence of the iron need for the same single insurance policy to deliver, the sequence itself becomes infinite. Well, that's basically the contribution of the economist Leontiev, who most of his life worked in the States, at Harvard University, and received the Nobel Prize for his work. Well, he delivered a very smart mathematical framework to answer such questions and to turn the infinite impact calculations into a single algebraic formula. So that was a big breakthrough. So you can basically, with a high precision, answer to any of these questions. How much of any resource in your domestic economy is used by any of the other industries? Well, so if we move, well, this was the example from the monetary, right? The monetary input-output table of the specific country. Well, the question is, how then we turn to the environmental questions we want to answer, right? And that's where we enter the territory of environmentally extended input-output tables. So basically, these are the same tables, but added to those financial transactions in your economy, you have information regarding the resource use by each, let's say, the extraction of material by each industry in your economy. You have information about the environmental pressures, different pressures like emissions, land use by each industry, the waste produced by each industry. So if you apply, if you're able to find that information in your country for each industry, and you add that to your input-output table, somehow magically the same calculations proposed by Leontiev allow you to answer questions like, what is the total carbon impact of a vehicle or a laptop which I just bought? You bought a single laptop from an electronics manufacturing industry. The same algebraic equations allow you to follow the infinite supply chain in your economy and add up the small contributions, the small carbon impact in each industry which is involved in a laptop manufacturing, right? So let's look into a different example. Basically, it was a vehicle. So this is your vehicle, which has been manufactured at the factory, and you're now driving it. What we're all used to when you think about transportation, of course, the impacts, the carbon impact of our driving, right? When you're driving, you're burning the fuel. There you have your 50 kilograms. At the same time, prior to you purchasing the car, it's been manufactured somewhere, right? And the same input-output analysis framework allows you to answer a question: how many kilograms of CO2 emissions are emitted by the factory for each dollar spent on a vehicle, right, by a consumer who purchases the vehicle from the factory. At the same time, there's a second order effect, because the car factory uses steel, and the steel production, a different factory or smelter, they emit their own emissions, right? So again, you go back to the same situation when you add up smaller and smaller contributions from all the players in your economy back in a supply chain of your product, but they still exist. You still have to add them all up, and the input-output analysis framework allows you to do that for carbon emissions, for land use, for any kind of environmental pressure, if you are able to add that data to your input-output table in your country of your domestic economy.
How do you account for trade here?
Well,
so whatever materials is imported.
Yes, so let's say the car manufacturer is located in your own domestic, in your territory of your country, and this data, how many kilograms per dollar spent, comes from your own statistics bureau, right? Well, this data, if a steel is produced in a different country, in a different region, then this is where the trade happens, right? And you probably know how much steel is imported, but to answer the question, how much kilogram per steel produced in a different region is emitted, you have to go into their data sources.
So, but you import the emissions in your calculations?
Well, if you say, it depends on the constraints which you set in your system, but the complete input-output analysis automatically, yes, includes all the trade-based embodied emissions. For that, you have to link the input-output tables of all the other countries in the world, right, to answer that question specifically, detail. If you have only your own domestic picture, only your domestic input-output table, and this is actually happening in the different regions, then you basically do not account for that anymore. You know how much steel is imported, but you do not account for their environmental pressures.
So just to push that a little bit, if I'm Armenia and I don't have good statistics, I don't have input-output models, and I'm definitely not environmental. So that statistic gets lost in the metals that go to Germany or to...
It is lost, and it happens not only in Armenia, but many countries actually prefer to pay more attention to emissions, at least in Europe, because so much is imported. They prefer to take an approach of calculating emissions only from a production perspective. So they remove everything from a picture which is not produced in their own country. Say there is a car manufacturer in the Netherlands, but electricity is imported from Germany. They say, we don't care what's emitted in Germany, we care about our own emissions. And politically, it's quite often it's beneficial to take the production approach in those. The input-output framework indeed allows you to connect all the regions to each other. For that, you have to have basically, yes, for every country in the world, you have, in ideal situation, you have to have the input-output table, their domestic table. It's not usually the case. For many countries, you end up estimating those from rough numbers, and that's what we do in our project too. So again, Armenia can approach this question differently depending on what the specific questions are, what the interest is, to what kind of picture present, unfortunately. So this is a bit ambiguous where you draw the border in these calculations. So just as an example of what kind of results you can observe delivered by the application of input-output environmentally extended input-output framework. So this is the graph which shows you on the bottom the there's a total final consumption expenditure by specific product type. So let's say eating and drinking, right? So this is how much the average consumer in Europe spends on eating and drinking. And on the y-axis, you see the impact per dollar spent in that category. So accordingly, when you multiply those two numbers, the area of the box is the total environmental impact of that specific consumption type. So this type of information comes from input-output analysis, right? Because to your eating and drinking industry environmental impacts are related to all the industries in your country, in your neighboring countries, etc. Like to have a very reliable picture to answer the question of which consumption categories of your nation are the most damaging, you have to go back to those tables. But in the end, you have a very interesting visualization. You can, I mean, most likely some kind of consumption, flying and intensive wine production is probably somewhere in this corner, but the share of your average household's expenditure in that group is quite low. So yeah, it's interesting to compare. In the end, you can see, well, where is the most of the emissions concentrated? In driving, right? So if you want to kind of intervene with a single policy right now, most likely you have to think about, working around some policies related to transportation, right? And that's what happens these days. A lot of talking is happening around the transportation issues. Why? Because, well, you observe these kind of pictures first. That's where you get the information on the priorities. Now I'll switch to talk a little bit about the project we work on with all these European partners for years already. Well, it is basically another input-output table with some environmental extensions, environmental data attached to the economy, which allows you, but we focus specifically on the metals, on the critical metals entering the European economy. So there's 14 critical metals we describe, and a couple of base aluminum and iron metals. You can see which specific ones we have taken into consideration. And the objective of the project is basically on a very detailed level for each product, or for each of these metal materials, describes the flow of those metals in European economy. Well, the input-output table is in a way it's a monetary flow in your economy, right? So-called physical tables are the flows of the mass of the material. In case of our project, this is a table describing the flow of the metals in the economy. Well, the life cycle of the metals starts from mining, then it goes into the production and manufacturing of primary and secondary products. Then the use phase happens when the final consumer, the household, purchase the goods in your economy, and then they at some point they discard the products, or the industry discards the capital goods, the factories they build for manufacturing. So all the industry and the final consumer are these two antagonist players in each of the economies. Well, so in the end, we strive to connect as many countries into this material flow table as possible. Some of the regions are aggregated in the bigger regions if there's no enough data from the regions. Described on a very high level in our input-output table. Well, what is the methodology? With industries. In practice, what we are table is only this single region inputs. Now this table refers for all the countries and all the metals.
You're on mute and we can't see your screen anymore.
Thanks for letting us know again. Do you see the slides now and you hear us?
Yeah, it's just the last slide you were describing.
Okay,
Yeah, this one. We didn't
So
hear.
how the environment extended input-output table looks in practice. So, well, the input-out table, just a small corner. Then you have and actually it duplicates in two tables. One, the input of products. The other side is the supply of products. Oh, the supply of products and the use of products. You have the environmental emissions. You have waste related to your households, right? You have resources sometimes input by your households. Each country you have to supply the data from various sources, so it's a very long process. So the methodology itself is not very complex, but there's a lot of estimations, a lot of models in place which you have to invent to products, which countries does it trade with, which products does it trade with countries, how much of different metal resources are different regions in the world extracting, what are the material content of the products. When you're trading the products between the regions, it doesn't tell you how much aluminum are totally traded between the countries, right? If you're trading 100 laptops with your neighbor, you have to know how much aluminum is in each laptop to estimate the total flow of aluminum between your country and the neighbor. It's not just the raw material, of course, right? Because again, the aim of the project is to describe the total global flow of a single material. So the composition of different products which are traded. The consumer expenditure surveys allow you to describe how much your citizens are purchasing different goods. Because input-output table in the essence is a trade between the transactions between the industries. Well, for that, there's another big player, which are the consumers, right? For whom those goods are produced. In different languages, so they're all describing similar processes, talking about similar goods and materials probably, but then they classify them using different so-called classifications. So what we have to do is to somehow link all this unrelated data in the beginning to be able to combine it in a single table. Well, the results. Currently, project is not finished yet. What I can show you is, so for example, for the year 2011, we have material flow description for basically any of the metals which are considered in the project. They're described on a very detailed level, around 2,000 products.
Is SUT?
This actually, yeah, the supply and use tables are more detailed extensions of the input-output tables, but I didn't want to go into detail. But that's when you start distinguishing between not only between the industry transaction, but how much does the industry output and which in terms of the products, not only the industries it's trading with, and how much it inputs products. It becomes more complicated, but yeah. So, and we have delivered a web portal as well, very beautifully looking, which we can of course explore already. So if anyone is interested, let me know. I will share the link with you. Well, that's example for the result we have. This is only a single country, Denmark, trading the copper flows in a domestic economy of Denmark for the year 2011. So these are all the products on the left which are imported into the Danish economy. The copper flow for kilotons of copper in copper products. So, to copper in motor vehicles. It doesn't show which country it came from because the graph will become super crowded, and it does not really extend to all the 2,000 products, which I told you is a level of detail. But actually, you can go to that level of detail and see in a very specific products how much copper comes in. You see how much is extracted in the country itself from its own resources. You see how much goes into the final demand, etc. So in the end, you have a very informative pictures of how different metals. This is, for example,
can we go back there? This is the emissions, waste, and stock addition. That's not energy emissions. That's just what
that's
emissions
the copper
are.
which ends up from your industrial, from your intermediate consumption ends up in the emissions. It could be in the air, in the water. The copper which is wasted.
It's only copper. It captures only copper.
It's focused on a very specific material. And actually, at this page of the project now we have this all separated in specific categories. It's not grouped anymore. On the web portal, you can observe much more detailed picture for those. And for example, the waste of copper by the industry is now linked to supposed to be linked to the resource use, because it's not only extraction where you get your resources from, but you can recycle existing materials. And that's where the policymaking can look at the picture and see, only this portion of the total copper use is recycled, right? That's where you get your recycling rates from, and see which proportion of the total copper is recycled, and see which whatever imports you rely the most in terms of the copper, right? And it doesn't have to be the primary goods like copper products directly. If you have a very strong recycling facilities, you can rely more on the finished goods and implement your urban mining policies, for example, if you see that there's a lot of that coming in. So this is another picture for tantalum, well, very specific metal which is used in electronics, in medical devices, in a lot of weaponry, and well, it's a very rare result, to see for a specific, again for Denmark, but it can be observed the results for any European country, and actually for any other country which is part of our project, but we have the most accurate result for European countries. You can see how much tantalum is going through your economy. It's a very rare and critical metal in that sense, and it's very important. And the last picture of the results I would like to share with you describes how much, in this case, copper is accumulated in Europe, has been accumulated in Europe in 2011, just to get a glimpse on the levels of flows here. So this is a list of all the European countries. And the bars are,
Germany is the most aggressive accumulator.
Yeah, the bars are basically that's the difference between the trade flows and those extraction which happens in your own region. Some of the countries you can see actually rid of the copper, but in total, the accumulation rates in the European region are extremely high, which again suggests certain circular policies. And the last chapter of my talk I wanted to devote to another tool which is called lifecycle assessment, but which is often which is very similar to the input output. and has many common goals in a way to describe the environmental impacts related to a single use or production unit, but it has a very different approach. So this is a, I haven't spent much time on this graph at all, but this is a family of different tools which are used nowadays to estimate the material flows or describe the material flows of a specific system you're interested in. And you can see that the input-output analysis, which I just briefly introduced you to here, is a very has a very low level of detail, because you're talking often just about big sectors of big countries in general, right? And this is a big sector of the country with a specific amount of CO2 emission being emitted by that sector. It's a very low level of detail, but it's a very comprehensive, complete picture, because you have all the countries in the world connected, all the industries connected, and that's where your politics start, discussing who has to emit more or less, right, and in which sectors, etc. The life cycle assessment tool is used for the same kind of questions, but it starts from the bottom up. It takes a very detailed approach to those questions, but you lose the level of completeness. I'll show you several examples. Well, first I'll just very simply describe the life cycle approach itself. So again, it's a very detailed approach. You start rather from the countries and industries. You start from specific products you're interested in. So if that's a vehicle and you're interested in what is the carbon impact of driving your vehicle, of course, again, first what comes to our mind is the fuel which you're burning. It's part of the vehicle's life cycle, but there's many more phases in its life cycle. Even prior to you starting driving the vehicle, it was manufactured. You want to include those emissions which were caused by manufacturing of your favorite car. There's the manufacturing of the components for the manufacturing factory, right? The material which is extracted for those. In the end of your vehicle life cycle, it will be somehow treated on the at the recycling facility, and that demands some energy, some water, so it emits another portion of emissions. So what you want to do for every product you are considering is to go through all its life stages and add up all the contributions, let's say in energy use, to have the full picture. An example for hand dryers from one of the studies, 10 years old, to put the citation on this. But well, as a simple consumer-oriented question: what kind of hand dryer is better to use, right? Are paper towers more damaging to the environment than electric dryers? Because one uses materials, others are using energy, right? It's difficult, and because they're demanding different, and they're introducing different environmental pressures, you cannot simply answer that question for all of the pressures. So you start dividing your question in more simple one. It's simple ones. What is the most resource efficient with hand drying? What is the most damaging in terms of the greenhouse gas impacts if you're worried about the climate change, right? What is the most toxic if you're worried about the ecosystem, etc. So it depends on the priorities, but let's take one.
So on balance, paper turns out worst.
Sorry?
On balance, paper turns out worst.
On which one?
On balance, overall, paper seems to be worse. Paper towels seem to be worse.
Yeah.
And this wasn't funded by Accelerator, right? This research.
There have been several of them actually. So it's one of the favorite topics is the hand dryer. I'm not sure who this one was funded, but
Yeah, the winner is
most of them have the quick hand dryer being the best choice. So there's been already several of them, and they kind of all come to the same conclusion. Well, again, what's interesting here is that, of course, you see that different life stages contribute differently to your total impact, right? Of course, the electric dryer, some big contributor is the use phase. That's where you use the electricity. You don't have that for paper towels. You have a lot of emissions originating from your paper manufacturing. That's why life cycle assessment approach is kind of often much more lively because you can kind of touch and see where are your impacts coming from, because you're investigating a very specific product for a very specific question. This is an example from my study I conducted for super unrelated thing. This is actually car sharing system. So it's not even a system, a single product. It's not a specific product. This is a kind of a behavioral attitude, right? How do you travel in your town? So I've considered 3 small regions as not have been considered as well. Answering the question, what happens after an average car sharing user in the city, in the region, switches from
Before and after?
that's the individual's impact before and after starting participating in the platform, and their average users' yearly mobility-related impact in terms of the greenhouse gas emissions.
Sorry, can you repeat that, please? We lost you for a second.
Sorry, what was the last thing you heard? The graph basically again describes how much emissions per year does the regular citizen of that region emit before and after participating in a car sharing platform which is provided in that region. Or how is the life cycle assessment related to that? There's different modes of transportation, buses, cycling, car driving, train in the urban areas, right? The car sharing itself, the blue bar, and all of these modes of transportation, you can say they have different impact factor. Right, your town.
So, but just to understand this, so let's say Netherlands, before you're emitting 2,250 kilograms, whatever.
Right, the average
average, yeah.
Citizen of the country.
And a big chunk, 2,100 or whatever of which is from car driving,
Most of it, yes.
private car.
Yes.
You go to shared system.
You started participating in yours from time to time in your
So the car
sharing.
share goes up, your other section comes down.
Your driving is reduced significantly. Your public
No,
transport mode increases.
Is this because of the embedded gets shared, embedded carbon gets shared? Why do I drive less?
You drive less. Well, that's the statistics from the users of the car sharing platforms.
So if I'm car sharing because it's priced,
Most likely because you have, on average, you have less vehicles in your household if you're participating.
so but
in such
so
platforms.
this statistics includes the embodied
It includes
stuff.
everything, all the modes of transportation and your.
No, but not only the emissions, the use emissions, but the embodied.
Oh, no, everything. Yeah.
Yeah.
There's several graphs in the paper, but it's only the final results, which accumulates all the emissions from all the life cycle phases. But that's where it exactly links to the life cycle assessment, because you want to link it to the. What's interesting, because a car which is shared, the benefits come from manufacturing mostly, because the single car is manufactured, but then it's shared. The manufacturing impact is now divided between several users. The driving impacts are the same. If you're continuing driving the same number of kilometers on your own, it doesn't matter if that's a shared car or if it's your own car, right? You're still burning that fuel. I mean, but that's a different part of the analysis in the paper. But yeah, that's just the kind of the strong side of the life cycle assessment tool for estimating environmental impacts is that you can pick a very specific product or service or whatever, and model a very specific behavioral process in a very specific region. So it's kind of, that's where the power of LCA focuses on. I think it's the last slide, just the most recent research I just finalized. This is not a very realistic picture, it's not realistic at all. But it just shows you another way how you could apply the life cycle analysis tools. In this case, very different question. How much copper is there in a laptop. Because such information is actually very much required nowadays by various institutions just to estimate the material composition of different products. This information is often very closed and private. And but when you have a very nice extensive supply chain described, then you can start what you can start doing. You can start filtering those exchanges between the industries or the products or the components, distinguishing between those which enter the next product or do not enter the next product. And if you do that and remove all the red links here are those which do not become part of the next product. For example, the refined copper enters the circuit board. Yes, it becomes part of the laptop, but the copper which goes into the factory manufacturing does not enter the laptop. Factory does not enter the laptop. So this copper amount which went into the factory manufacturing does not become part of the laptop itself in the end. It is its material footprint. You need that copper, going back to the very beginning of my talk. You need that copper, you need that iron to deliver that laptop, but it does not become its embodied part. So if you apply such mathematical filtering techniques during your life cycle analysis, you can, for example, in terms of this study, you can end up being able to estimate the content of different products, their material composition. So yeah, that's kind of a very different example how these tools can be applied. Just to give you a bit random, but I hope at least a little bit connected to each other ideas how environmental impacts are assessed and the work I do. Thanks for the attention, and if any questions or anything.
Questions? Online people, do you have questions?
Thanks very much, Alan. I have a question.
Please go ahead. Yeah.
Thanks, Levon, for a great presentation. Perhaps this question is going to come a little bit abstract or very theoretical, but both in your input-output model or life cycle, you kind of defining a kind of a limit or battery limit for your calculation. For example, in your example regarding car, you go all the way back to the mine and consider the the extraction of ore as a kind of starting point. But in fact, if you look at the mine operation themselves use trucks. So the same value chain can push back again through the same steps and going further and further. So my question is, in any of your approaches, either input-output model or life cycle, how do you define your starting boundary or battery limits?
Well, that's that's a very reasonable question. That's basically one of the things which you have to kind of decide before you conduct any of your LCA studies. You have to tell where is your border, what's not included. For example, in case of my car sharing research, the emissions related to the transportation infrastructure, of course, are very extensive, right? So I use a study which said, okay, we will consider the roads, we will consider the rail tracks, we will consider the train stations, we will consider the electrification of the train stations. But they did not consider the, I don't know, the maintenance of the railroad, for example, only its manufacturing, right? So you just start with this, again, if your question is about LCA specifically, yeah, that's a very base question. You start with you write down a big list of all the things which will be included. You start to argue why you assume that this specific list will be covering around 90, at least 95% of the total emissions. And that's, yeah, and then you proceed with a limited list of the life phases and the factors and parameters you want to consider. So that's a very, I mean, it's always a very tricky question in the beginning. How do you make sure that this list which you have end up with, all the things which you'll be considering, really contributes to around 95% of the total? But that can be estimated from the total emissions in the whatever region. So that's yeah, that's a process which requires some time.
But an argument could be made that, for instance, if you want to calculate total, then let's say railroad tracks are part of the total. But the tracks, are they amortized? So maybe by now they're completely not worth putting into the system because they've had such a huge, use over the past 50, 60 years where it doesn't make sense to include them in.
Yeah.
And
No, there, of course, you consider that too. You consider there's a so-called, I'm not sure if it relates much to it, but it's a so-called prospective LCA, where you not look onto the static picture right now, but you look into how the system changes. So your impact factor will be dependent on the future changes of the system as well. But of course, things are divided by the total lifetime of the track. You know that the track you built, the railroad itself, will last for 20 years. You divide your emissions for a kilometer of railroad by 20 years, and then you divide it by the number of kilometers of the average, whatever, how many kilometers trains ride through that railroad during a year. So you end up having an estimate of 1 kilometer train driven through this railroad, which will last for 20 years. So lifetime indeed is a very impactful factor for any of the LCA studies as well. Yeah, but for the input-output analysis, there is this kind of initial benefit that your system is closed already. It's very comprehensive, so you don't really need to worry about the constraints that much. Then it's more about the politics. You can say, I care about my own domestic emissions only, and I do not consider trade embodied emissions. So I do not. I do calculations only in my domestic table, input-output table, instead of doing the whole world kind of fair analysis. But
so,
yeah.
So if I could just, so with input-output with LCA, the common criticism is this is massive amount of work. Right? How practical is this to have this as a policy tool? I mean, you have done a massive amounts of work in year 2011 is the latest data you can really put out there. And the world is 10 years gone, So, and then how representative was 2011? That's the other question, right? So, are there any tendencies to use these, make these tools a little bit more practical, not so rigorous, but a little bit more practical to get these decisions at a rough level done more quickly?
Well, the physical tables, because our project is designing a physical material table.
Yeah.
This in general in the field is quite rare. There is one big famous one, it's Exibase. Basically, what we're creating is an extension of the table. So if you go back one step back to the monetary tables, then there's dozens, if not hundreds of countries investing on a yearly basis, publishing new input-output tables, monetary input-output domestic tables. So there's big, departments at the local ministries who spend a lot of time on that work on a yearly basis. So I don't
Do you
know.
find that in EU with circular economy approaches, they're looking at more material flows now, or they're collecting more, not value flow, but material
flow? Yeah, it
mass
has
flow.
not been even closely systematized on the level as the monetary table has been. So I think our project is in a way is a trial for EU to see how labor and time demanding those kind of tables can be to produce. But yeah, going back to your original question, I don't think there have been any other alternative tools to that which are less time intensive but deliver same satisfaction to the policymakers and stakeholders using them.
But then the question is, do you really need that much detail to make correct policy decisions? Because like once you know this is the direction you should take, you don't need to know with like 10 numbers behind the comma, what the numbers are. You just need to know the general direction, and then you need to do it. So do you think this may be
Depends
over?
on very much on the question. So yeah, what it allows you to do is to observe how much tantalum enters your country in the laptops, let's say, specifically, right? So that becomes important at the point, I think, when you start answering questions, which products in my region I have to recycle? Which products do I have to recycle, focus on recycling? I don't think you'll be able to answer that question if you have a more general picture of the total tantalum, or even if you have it.
Do you have any idea of the uncertainties involved in such a statement when you say total amount of tantalum in laptops? Because I know they switch out tantalum capacitors for other types of capacitors at will. Well, not exactly at will, but they can do that quite easily depending on the price. That doesn't show up in any of this data.
Yeah. It's we do the qualitative uncertainty analysis, so it's scored from 1 to 5. The products in the input-output analysis, which would do the quantitative, it's basically doubling the time of the total. Yeah.
So what do you
work
think?
on the project.
Just like 50%, 100%, 10%. Oh, you have to have some kind of idea of the uncertainty if you want to be able to go to policymakers and say, oh, you should make a decision based on this data. And say, how certain are you? You're like, roughly.
Well, we have to come up with a final estimate. Yeah, I think when the project ends, because now kind of we connect more and more data in. But the similar projects like Prosom, which would do similar things, they would estimate like around 30% up and down, which is a lot. But we use very similar data with them, and they kind of they focused on a very specific set of products, so they didn't take that long for them. We're kind of describing the whole global economy for a lot of elements for all the products. They did only electronics, so they had the time to estimate the uncertainties more specifically, and it will be something around 30%.
Lori, you have a question, right?
Yes, I do. I'm just wondering, in all of this, how accessible is the data that you used, and the list of the databases that you provided, are they open source? I'm just wondering how easy it would be for someone like me to take on an LCA or an input-output.
Lori, can you introduce yourself? Because I think it's valuable that you guys know each other.
Hi. Okay, so I'm a PhD student at McGill in materials engineering, and I'm working mainly on phosphorus, and I'm a member of AIMS, so the Armenian International Mining and Metallurgy Society that was created not too long ago, I think about last February or January or February. So I've been having meetings with Alen discussing the interesting future of Armenia and some potentials. So
Very nice meeting you, Lori. Nice
meeting you too.
Well, so regarding the data availability, if we talk about this list I have here, it's most of this data is available. What complicates things is that often, if you want to obtain the data in a big chunk, for all the regions at the same time for all the years, you have to pay, or you have to submit a specific request. But in many cases, if you're interested in a specific production or trade volume in a specific region of a specific product, most of these data sources, they have web portals where you can specify again exactly where and what you're interested in, and they will give you the value. If you need more specific information on that, I'll be happy to send you the links.
Yeah, that would be great.
So
I'll give you the email. I'll connect you guys.
Again, just to underscore, the challenge usually is not the secrecy or the cost of the data being closed. It's just that moment, if you really want to aggregate a lot of data at the same time, then that's where it becomes difficult.
How much of this data would be available for Armenia? Have you looked?
Well, for example, the production data Prodcom covers European regions only. For the regions for the other countries, we have used national statistics one by one. So there is a production statistics for Armenia. There's around 30, I think, industries described there. So I'm not sure you get data on the product level quite detailed. In terms of the trade, that's one of the best data. So if you go look for these databases, I'm pretty sure you'll find very detailed product description of Armenian trade. The IRP data for material extraction, pretty sure it's quite clear for Armenia as well. Yeah, so it depends. I think the production will be the biggest challenge for Armenia.
Thank you.
If you want to go into the more detailed level. Yeah, the waste statistics, of course, yeah, one of the hardest usually to obtain. The consumer expenditure surveys, that I don't know about Armenia. Might be on the even on a bit detailed. I don't know how detailed is it? Do you remember? Because that's usually the data which allows you to answer questions like which consumption category in your country is the most damaging and which one you want to use for policies. Yeah, but thanks for the questions, Lori. Yeah, you drop me an email and I'll send you more detailed links to these data sources.
Thanks a lot.
Hi, thank you for the presentation. I have just one question relating to when you were discussing copper, I wanted to understand how detailed could that analysis be? Because if we go to the copper slide, we're looking at how much copper is being used to make a specific part of the product.
You mean this slide or the?
No, the one in the end, yeah. But what interests me as well, sometimes what will happen is that we're saying that it's copper that's being used, but in reality, this piece of copper only has 50% of copper in it. How detailed does this type of analysis take that into consideration, that this isn't just copper, it's
an alloy.
It's an alloy. Is that, does it go to that level or is it a bit higher?
It actually does, yes. So this is a methodological research, but it's based on the real example of eConvent database. I'm not sure if you heard of it, but it's one of the biggest data lifecycle inventory database in the world. So it basically describes thousands and tens of thousands of different products, goods, and you'll find dozens of types of copper products in there with a very specific copper content in them. Different, primary and secondary copper containing products. So it is actually accounting for that. But not for all the materials. So for example, the copper might be very well presented in that database. And you can do really very detailed analysis for your copper flows using such databases as eConvent. But it doesn't necessarily be the case for glass. You know, it depends. You have to be careful. But it's a valid question and it's exactly it's approached in this analysis.
So Harut, do we get waste data out of this? So can you go back and figure out if you have waste?
The waste is the worst. So it's in the end in our projects the same as many others. You model the waste flows using the lifetime. So you know your consumer expenditure survey data, how much money spent for different products in your country. You multiply that by the average weight of the product per dollar, the price weight coefficient, so you get your approximate mass of the laptops consumed in your country. And then you multiply it by there's the statistical model for the lifetime. What's the average lifetime of the laptop? Sometimes in a specific country, sometimes data is quite rough. And then you can say in 10 years, this amount of copper will be wasted in this region in the laptops. And then you do it for all the products. Yeah. That's how it's done.
Easier to do it for a certain product.
You do it for, if the consumption data is comprehensive and it describes all the categories of consumption in your country, and you have the weight. I mean, we did that. There is data for that. How certain is that? And I mean, most of the high-level input-output kind of projects, that's what they do. connect the expenditure surveys to the lifetime statistics to estimate the total waste flows or the household stocks. How much is there in the house? What you were saying.
By the way, consumer expenditure surveys, they wouldn't include this public.
No. Yeah.
Institutions,
Yeah.
e-waste or.
They wouldn't. Yeah, that's a big problem.
Which is a major component for e-waste. We have a lot of computers. Ministries.
Yeah, that kind of stuff you have to.
As the public
estimate.
sector is not a consumer.
It is one of the final
The
demand.
surveys
But not,
wouldn't, include that.
It is consumer. Yeah, it is consumer in the theoretical framework, but yeah, the surveys do not survey the government or non-profit, often more organizations. Similarly to the industries as well, because they have their tracks and stuff that becomes waste at some point. So that complicates things. But at least they have statistics on that in countries like European countries have statistics on industrial waste because they have to be accounted for compared to the households. They can report how much of this and this waste. Again, no idea about the Armenian case. The thing I know is that there is a production data for Armenia, and it's not on a very detailed level. There is, of course, trade data and extraction data.
Actually, it's ridiculous. They collect industrial waste data, but it's not aggregated by material or waste type. It's just aggregated into 4 classes of hazardousness of project.
Oh,
That's it.
you don't know what kind of.
No, that's ridiculous.
It includes manure, right?
No.
Manure is not in there.
But I mean, in any
They
case,
don't report.
the first step for Armenia would be start with the monetary table, because physical tables, the input-output tables, in many instances rely on the monetary data. So.
Okay, guys, any other questions from our online friends? If no, we're already 15 minutes over time. And thank you very much, everyone, for joining. And we look forward to continued discussions. Thank you, everyone.
Thank you. It was very interesting. Thanks.
Contact, I hope. Thank you.
We have to stop the recording first, right?
And for
Are we
that,
controlling that or
It will automatically
Process it to
process the video.
record? Okay, so I guess you stop and
No, you end the session and it will generate the video.
and meeting for all.
Yeah.